In this video, we're going to look at writing polynomial functions from graphs. The warm-up is just reviewing what the function of a graph kind of looks like. So we've got ourselves three intercepts. It's common for students to think that the only x-intercepts that are available are at -3, because when we substitute a -3 and we get a 0, and +4, because when we substitute +4 and we get a 0. But there is one more, because if we have a little x in the front, whether it's the power of 1, 2, 3, whatever, that also counts as an intercept, because this is the same as x plus 0 to the power of 3. Or if we were just to plug in a 0, we would get 0 for x. So 0 is also an intercept as well. So right now, with this information, we only have that we're crossing the x-axis at -3, 0, and +4. For this one, we also need to know what direction we're going, like how to actually get the graph drawn itself. And for that, we need to use end behavior. So to calculate your end behavior, we're going to start by looking for the degree of the polynomial. The degree of the polynomial is the highest exponent in standard form, so that's after it's all multiplied out. So I'm curious about how many x's I've got in total. I've got 3 x's up front here, but then I'm multiplying that by another x to the power of 1. So that x to the power of 1 is adding one more exponent, and the x to the power of 2 is adding 2 more. So that means that in total, I've got 3 plus 1 plus 2, adding those exponents up, and that's going to give me 6 for my degree. So I've got an even degree, x to the power of 6. The other value that you need for determining end behavior is the leading coefficient. And the leading coefficient is that leading coefficient, the coefficient in the front. So our leading coefficient is -2. Now we've got two choices on how to tackle what our end behavior is. The one that is most commonly used is looking at the basic forms of quadratics and linear functions. Because if you know that a positive quadratic function looks like a u going up, up, and a negative quadratic function looks like a u going down, down, that's a good start, because then you'll be able to see that since we've got an even degree, 2, 4, 6 all look the same, then it's going to follow one of these. And since it's a negative leading coefficient, then it's going to be this guy here. It's going to be down, down. If, however, you're not sure about these graphs, then let's look at a different method. So the other method is looking at the other two forms. We've got positive x and negative x. Positive x goes down, up. Negative x goes up, down. And so let's say that you didn't understand the basic forms of these graphs. If you were to look at your leading coefficient sign, you've got a negative there. Well, these are both negative here. And if you see, both negatives end going down. So that's a good starting point. So you look at your leading coefficient and the end of it is going down. Likewise with the positives, they're both going up at the end. The second part to determine whether it's going up or down on the left-hand side is to look at your degree, because if it's an even degree like we have for the 6, then it's going to go in the same direction. If it's an odd degree, like 1, 3, 5, 7, 9, it's going in the opposite direction. So these first two, the quadratics, go in the same direction, and the linear functions go in the opposite direction. So that's another trick you can use for tackling the end behavior. So that we're going down, down in this case. So down, down. So let's get our intercepts drawn again. We've got -3, 0, and +4. So that means that our y-axis is going to go through the origin. And the second thing that we need to identify is whether we're flattening, bouncing, or crossing. So let's look at those exponents again. So I've got an exponent of 3. That is for the x. So that's going to mean that we're going to flatten at the 0. We've got an exponent of 1 for the 3. That means we're going to cross at the 3. Cross. And then we've got an exponent of 2 for the 4. So that means we're going to bounce at the 4. So you look at each of your exponents for each of your factors, and each one tells you a different thing. The 1 is a cross, the 2 is a bounce, the 3 is a flat. So I know my end behavior, which tells me I'm going to go down and down. For my graphs, I'm starting down here, Going up, I'm going to cross at the -3, flatten, and make it a good old exaggerated flat at your origin. So it's like you're crossing, but you're flattening out as you cross. And then a bounce at the 4. So that's going to be the graph of the sketch. Our goal today in this lesson is to look at these equations or these graphs and write an equation of it. So it's fairly similar to what we were just doing, except for undoing the work. So our step 1 is going to be to identify your intercepts and write factored form. X-intercepts. And write factored form. So what that looks like is we've got 3 intercepts, making sure you're looking at the right ones. We've got the 0 down there telling us the x and y axis is crossing through there. So I've got an x-intercept at -3, +4, and +8. -3, +4, and +8. So when I write my factored form, my y is equal to, we are trying to figure out what the a value is. We don't know what the a value is. But for the x -3, we're going to have an x +3, changing the sign. For the 4, we're going to have an x -4. And then for the 8, an x -8. The second thing we need to figure out are if there's any bounces or anything like that. These are all crosses, though. They all cross through the x-axis. So that's a cross, and a cross. So they all have an exponent of 1. So we don't need to write an exponent for that. So for the second part, step 2, we're going to substitute the point. Substitute the x and y and solve for a. So we've got a point up here that is -2 and +120. So I'm going to use those two values for my x's and y's. So my y value is 120, and all of my x values are -2. So a times -2 + 3, -2 - 4, -2 - 8. So when I type this whole thing into my calculator, it gets 60. So I have 120. 120 is equal to 60a. So then I can just divide both sides by 60. And I get that a is equal to 2. So lastly, we want to write the final equation, which is y is equal to 2 times x + 3, x - 4, and x - 8. The last little equation, same idea. We first start by identifying, so I'm just going to write step 1. We're identifying the x-intercepts. So I see 3 of them. We have a -2 right here. We've got a 0, and we've got a +1. So that means that my equation is going to be y is equal to a times x + 2. I could do plus or minus 0. I like to do plus. 0, and then x - 1. So changing each of the signs. But I see that for the first one, for -2, there is a bounce, or a flat. Sorry, that's a flat. We are flattening out. So that means I'm going to get an exponent of 3. At the origin, at 0, I've got a bounce. So I've got an exponent of 2. And then for the 1, it's just a cross. So I don't need to worry about that. I could add a little 1 if I need to, but it doesn't change anything. So then my second step is going to be substituting in the x and y values. Up here I see another point that's not on the x-axis. So my y value is 4, a, x value is -1 to the power of 3, -1 + 0 to the power of 2, -1 - 1. And so when I type this into my calculator, you do want to include those exponents. That's super important. And when you do an exponent of 3, so you're going to get to the exponent of 3, in my calculators, you're going to be pressing the little caret and then 3. So it's the power of 3 like that. For the exponent of 2, though, that's just like we've seen before. You're going to just press that little x squared button for the exponent of 2. So that's just a little calculator hint there. So caret 3 exponent of 2. In either case, and I would recommend practicing this on your own, we should be getting negative 2 for our a value. And so when we divide both sides by negative 2, we get our a value, which is negative 2. And so our final equation is going to be y is equal to negative 2. Now, whenever you have an origin passing through the middle like that, the x plus 0 squared, we put that in the front and just write it as x squared. X plus 0 is just x, so it's x squared. And then we have x plus 2 to the power of 3 and x minus 1 to the power of 1, which is just x minus 1. So that's going to be your final equation. I'm not going to be strict on moving the x squared to the front, but definitely strict on making sure your exponents are accurate. So that's it for the lesson. You've got some homework classwork that you can work on, and I hope this helps. Just as a little reminder, this first objective is for objective 5 for the warm-up. So this reviews that first objective, and the second part is objective 6, writing the equations.